Okay, hello, 大家好. Okay, so because I scared that we are not able to finish the syllabus on time before your trial SPM or even your SPM lah. Okay, so I will start the chapter 1 with a little bit of the what do we call as video class. Okay, so 这一个 video class 呢，我就是会放在你们的那个 WhatsApp group 里面咯。那 if let's say 你们需要 revise 的话，你们可以 revise 回去。OK, notes 那些呢，就是我们我有讲过嘛，我会 order 一本书给你们。那一本书呢是有 notes 有 exercise 还有就是阿玛丽在里面的，所以呢你们就是可以用那一本书 as 那个 notes。OK， 里面是有 notes 的，只是需要你们就是 fill in the blanks。OK， 所以如果说开学了 ，OK， 他的那个书来，你们就可以开始做。还没有的话呢 ，maybe 你们就是先稍等一下啦。OK，so 我们 Form 5的 syllabus，OK，the whole Form 5 syllabus there are 7 chapters altogether。OK，so chapter 1 and chapter 2是关系到 force 的。Okay, chapter 1其实是 the continuous of the previous chapter 2 in the form 4, which is force and motion. So 我们已经学到 force and motion part 1了，现在就是 force and motion part 2. Then chapter 2是 force and pressure. Then chapter 3, chapter 4 and chapter 5. Okay, chapter 3, chapter 4, chapter 5呢都是关系到 electricity and magnetism 的。Okay, 它像是一个 component 这样子啦，一个 element 在那边啦。Then chapter 6 and 7呢是关系到 quantum physics 的 ，OK， for example radioactivity 啦，还有就是 photoelectric effect 啊 ，so on and so forth。OK， so without further ado, okay, we will start our chapter 1 first. OK, chapter 1, OK， 我们有4个 subtopic 到完。OK， 在这一个版它没有像 chapter 2 form 4的这样多东西要读，它都是关系到 force 的。OK， 可是呢，在这一边呢会有比较多的一些 calculation。OK， 我们不只会学到 force， 我们也会学到一个东西叫做 elasticity。OK， 就是有弹性。OK， 所以呢，今天我们会教第一个 subtopic 先 ，which is the resultant force。Okay, so before we talk about what is resultant force, okay, I want to let you see this video to know what is the difference between balanced and unbalanced force. 可能你会讲 ，OK, balanced force 是平衡 ，OK， 在什么情况下我们会叫那个 force 是一个balanced force？ 什么情况下我们会叫那个 forces acting on an object unbalanced forces？ OK， 所以在 balance force 的时候 ，what happened to the object？ OK， then whereas unbalanced force 的时候 what will be happening to the object？ OK， so let us look at this video.
Balanced forces. The famous English scientist, Sir Isaac Newton, who lived between the 17th and 18th century, devised 3 laws of motion. The first law states that if all the forces acting on an object are balanced, there will be no acceleration, meaning either constant velocity or the object remaining stationary. But what do we mean by balanced forces? Let's look at the example of a horse. The first force we will consider is the force of gravity. This acts towards the centre of the earth. The size of the force of gravity is the horse's weight. An arrow is drawn downwards from the horse towards the centre of the earth. If this were the only force acting on the horse, it would sink into the ground. As this is not the case, there must be a force opposing the force of gravity. An arrow is drawn in the opposite direction, but equal in size. This force is called the reaction force. As the reaction force is the same size, but acts in the opposite direction to the horse's weight, these 2 forces are a balanced pair of forces. There are other forces acting on the horse. The horse is moving forward, and therefore there must be a driving force from the horse's legs. The driving force, though, is opposed by forces trying to slow the horse down. And if the horse is travelling at a constant velocity, the force of friction and air resistance are equal in size but opposite in direction to the driving force. The driving force is now balanced by friction and air resistance, a balanced pair of forces. And the horse now travels at a constant velocity. If though the horse accelerates, the driving force must be greater than friction and air resistance. The driving force is now no longer balanced by friction and air resistance. These forces are now unbalanced. So in summary, when the forces are balanced on an object, the object will either remain stationary or travel at a constant velocity. When the forces are unbalanced, the object will either accelerate, meaning an increasing velocity, or decelerate, meaning a decreasing velocity.
Okay, so 刚才呢，我们就有学到 what is balanced force and unbalanced force. Okay, actually, an object there are a lot of forces acting on it. Okay, 所以呢，可能它就是有一个 object acting，就是它这个是一个 pair of forces acting on it，then 上下又是一个另外一个 pair of forces acting on it。如果这个 pair of forces 它们是一样的 magnitude，but only in the different direction， 我们就讲说它是一个 balanced force。OK， 它是一个 balance force. However， 如果这个 pair of forces either one of it is greater than okay, it will produce an unbalanced force. Unbalanced force 呢，它就会 cause the object to either accelerate or decelerate. Whereas for balanced force, okay, 如果那个 object experiencing balanced force, the object will be either at rest, 还是 stationary, or moving with a constant velocity. Okay, so 这个就是一个 summary of what we call as the balanced and unbalanced force. Okay, so 我们就来看这一边。So have several forces acting on it. Okay, 刚才就像我刚才这样讲的，它是在一个 pair， 左右是一个 pair， 上下是另外一个 pair。记得一定要有一个 pair 这样子。Okay, so but if the forces are balanced, okay, they will cancel each other. So for balance force, 记得 balance force, 它会 cause the object to have two conditions. Either 是 at rest, 就是 what do we call as stationary, or moving with a constant velocity. Okay, so it follows the Newton's first law of motion. Okay, 我知道讲说你们讲 Newton's first law 是关系到 inertia， 可是其实 inertia 也是关系到那个 forces 的嘛，因为它一定会continue its motion 嘛 ，unless there are forces acting, external forces acting on it 嘛，所以就 fulfill 到 what we call as the balance force already 咯。Okay, so when two or more force acting on the object are not balanced, there will be a net force acting on it. Okay, so for example, 这是一个 object， 这边有5 Newton， 这边有另外一个5 Newton。给这两个，因为它是 same magnitude of forces but in a different direction. Okay, different direction. So 我们就讲这两个 forces are balanced， 因为它是 same magnitude. Okay, however 如果我加多一个5 Newton 在这边的话，它就会有 net force 了，就是说它有那个 force indifference between these pair of forces. Okay, then 这个 force 我们叫做 net force, which is what we call as unbalanced force 还是 resultant force. So net force, resultant force 跟 unbalanced force 三个都是一样的意思的。OK 啊 ，OK， 在这边又是有关系到 what we call as a force, balanced force and unbalanced force. So please take a look 啊。
Take a look at what happens when forces are unbalanced. Welcome to Moo Moo Math and Science and Balanced and Unbalanced Forces. Newton's first law of motion states that an object at rest stays at rest, and an object in motion stays in motion with the same speed and in the same direction unless acted upon by an unbalanced force. But how are balanced and unbalanced forces different? Balanced forces will cause no change in the speed of an object. Balanced forces acting on an object in opposite directions and in equal strength, as shown in the arrows below, do not cause a change in the speed of a moving object. Objects that are not moving will not start moving if acted on by balanced forces. Remember, forces have a magnitude and a direction. Unbalanced forces are not equal, and they cause the motion of an object to change. When two unbalanced forces are exerted in opposite directions, their combined force is equal to the difference between the two forces. The magnitude and direction of the net force affects the resulting motion. This combined force is exerted in the direction of the larger force. Let's take a look at some real-world examples. The forces acting on the red pull balls are balanced. The downward force of gravity is equal to the resistance force of the pull table. When the white ball strikes the red balls, the forces are now unbalanced and they move in the direction of the force. The forces are balanced on the weights. The downward force of gravity is equal to the resistance force of the yellow rack. The weights do not move. The weightlifter exerts an unbalanced force upward, and the weights move in that direction. The forces on the tennis balls are equal. They are not moving. When the tennis balls are struck by an unbalanced force, it causes them to move. The resistance force of the car is balanced with the downward force of gravity. The car jack exerts an unbalanced force on the car upward, and the car moves in that direction. The car is at rest, and all forces are balanced. When the car that is moving strikes the car at rest, then the forces now are unbalanced, and the car moves in the direction of this force. If you'd like to know more about unbalanced or balanced forces, this playlist will help. And as always, thanks for watching, and Moo Moo Math uploads a new math and science video every day. Please subscribe and share.
Okay, so 这一个 video 也是跟你讲关系到 balanced force and unbalanced force.
Take a look at
In short, resultant force. What is resultant force? Is sum of all the forces acting on the object. Okay,什么时候会有 resultant force 呢？其实无论是 balance force 还是 unbalanced force 也好，都会有 resultant force acting on it 的。只是 for balance force 的话，你的 resultant force 是 zero， 因为呢，它的那个the magnitude of the forces acting on the object is the same, but just in the opposite direction. Okay, so this causes the object to either at rest or move with a constant velocity. Okay, rest or moving with a constant velocity. So for unbalanced force, the resultant force is not equal to zero. Okay, 它可以是 negative value， 也可以是 positive value. Okay, 所以这个 negative positive 呢是代表说它的 direction of the forces. Okay, so the object will be either accelerate or decelerate. Okay, 这个就是 resultant force. Okay, so to determine the magnitude of the resultant force 有很多种方法 depending on what kind of questions or what kind of situation you are having. Okay, 所以 basically 会有4个，可以吗？可以加4个吗？对，有4种 methods to find the resultant force. Okay, 第一种 method 就是 when the forces are acting in the same direction. For example, 这个5 Newton, 这个4 Newton, 这是 acting in the same direction 的话，我们只需要把这个2个加起来。That will be your resultant force, which is 9 Newton. OK, 所以呢，这个就是第一种方法。第二种方法是 when the object, OK, experiencing forces in different direction. Okay, different direction. 所以 maybe 这个是5 Newton, 这个是4 Newton 的话呢，我们的 resultant force 通常 resultant force 我们会放这样子。Okay, it will be 5 Newton plus negative 4. So it will be what we call as 1 Newton. Okay, take note that 你看为什么我这边我会放一个加？为什么我这边是 negative？ 因为我们刚才上一个 slide 我们有知道讲说 what is resultant force? Resultant force is sum of all forces acting on an object. Sum 嘛 that's why 我在这边我放一个加 OK 在这边我放一个加在这边 OK 我放一个加 OK 而不是减 OK 实际上是减 OK 可是因为我要用那个 definition of 的那个 resultant force 来讲解这边 OK 让你们会比较记得的 definition of the resultant force OK 另外一个你要记得的是你的那一个 force 一定要 at the same pair 就是说好像我刚才有讲嘛这边左右是一个 pair上下是一个 pair 你才可以加来加去 OK for example 这边是5 Newton 这边是3 Newton 的话所以你的 resultant force 就是5 plus negative 3 so it will be 2 Newton so in short acting downwards 的就是 negative acting 就是如果左右的话就要 depending 总之是 frictional force 的话如果它是 frictional force 它就是 negative value OK 这是第二种第三种方法就是 when this object OK experiencing two forces acting at a 90 degree okay acting perpendicular to each other okay the forces acting on the object is perpendicular to each other 刚才我有讲过嘛其实一个 object 大多数都会有2 pair of forces acting on it 一 pair 是左右一 pair 是上下你只能在左右就是说他们是在这一个一样的平行线的时候你还可以就是直接加它还是直接减它 OK 上下的呢你可以直接加它直接减它可是如果说2个 forces 一个是 horizontal， 一个是 vertical，which means that 它是 acting at perpendicular 的话呢，你就不可以就是直接加还是直接减了的，我们就用另外一个 method， 就是 what do we call as Pythagoras 我不知道这样子 theorem 来算。So for example， 这个是3 Newton， 这个是4 Newton 的话 ，so your resultant force will be square root of 4 square plus 3 square. So it will be 5 Newton. 3、4、5咯，所以像刚才我就用这 Pythagoras theorem 来找。OK， 最后一个方法 ，OK， 对不起，还没有回啊。第4个方法就是 when the object experiencing two forces，OK，forces acting at a certain angle。你看啊，这个是90 degree， 这个是 certain angle，maybe 可以是30 degree， 可以是60 degree， 就是不是90 degree 的话，我们就要用 drawing method 来找出它的 resultant force。OK， 这个就是一个 overview of how to determine the magnitude of the resultant force。OK， 所以我们就一个一个来看。如果是 in the same direction， 很容易，就是把它加起来吧。所以它的那一个 direction 呢，就是跟着你的那一个 direction which is have a greater force。你看啊，所以你看这边是8 Newton。OK，so 它的 resultant force is 14 Newton to the right， 因为它是 following 这个8 Newton，which is the greater forces 的那个 direction。OK， 如果是 in different direction， 你就是其中一个要变成减 ，OK， 其中一个要变成减 ，OK， 所以呢，通常如果是这样的话，就是说你这边是你的，我的不见了 ，OK， 这个就是你的 forward force， 这个就是你的 frictional force，so 你把它减起来 ，OK， 你把它加起来，就是说这个是加一个减在那边。OK， 因为它是 acting in the opposite direction。OK，opposite direction 的话，有其中一个 force 就是 negative value already。So then 你就要找 negative 2。So 我们就刚才讲嘛，你的 direction 是 following the force with a greater magnitude。So 这一个8是 greater magnitude， 所以呢 to the left。OK， 所以这个等下你们可以就是 pause 下来，可以自己就是算看一下 whether 你们会不会就是找出它的 resultant force。OK， 所以呢，这个就是 either 是 at the same direction， 还是就是 different direction 的方法，直接加还是直接减就可以了的。可是如果是 at a perpendicular， two forces acting perpendicular to each other， 我们就用 what do we call as the Pythagoras theorem 来找。OK，Pythagoras theorem 来找。OK，so 就像这样子。Okay, then if let's say the two forces acting at a certain angle which is not perpendicular， 就是 at a certain angle already。OK， 我们就用 scale drawing。有2种方法 ，either 是用 triangle 还是用 parallelogram。可是在这边我会着重在 parallelogram， 因为 parallelogram 会比较容易画出来。所以下一个 video 呢是会教你们怎样画出一个 parallelogram，so that to find the resultant force when the two forces acting on the object is acting at a certain angle. Okay, so please take note on this video, yeah?
Hey guys, just want to make a quick video on using the parallelogram law to determine the resultant force. Okay, so what we have here is a barge is being pulled by two horizontal forces. So this is from the top view of 75,000 newtons and 50,000 newtons at an angle of 60 degrees. Okay, so if you were to use the parallelogram law, we know that to draw the parallelogram, both forces must start out from the same point, and it will move in this particular direction, it will move towards the left, right? Okay, so to start off, our first point, we need to make sure this is the most important point for us to decide, because sometimes if you start, most people start in the center. If you start at the center, you end up, your parallelogram law may end up outside the piece of paper, right? So you got to start a bit to the right and somewhere in the center, because you know this 75,000 a bit goes a little bit up and 50,000 goes a bit down. So you got to leave some space in for it to go up and down. And then since the forces move to the left, so we got to start from the right. Okay, so which is why you can see this red dot here. So this is where we start off. Okay, so first thing first, scale use will be 1 cm to represent 10,000 newtons. So roughly, because your piece of paper roughly is about 10 or 15 cm long, so you don't want to have something too small or too big such that you fall out of the paper. Okay, we want to try to maximize it. So you know, actually the bigger it is, the more accurate it is, but we don't want to make it too big, because something that's too big, if it falls out of the paper, you won't be able to calculate the resultant force, right? Okay, so this will be an optimal scale of 1 cm to represent 10,000 newtons. You can see, so here for 75,000 newtons, we have 7.5 cm, right? So first thing, we just put a ruler roughly in this direction. Doesn't matter whether is it northwest, northeast, no, because we know it's going to the left up. Okay, so we roughly move in this direction. So we measure 7.5 cm, you can see here, and we just draw a line, 7.5 cm, draw one arrow, and that's it. Okay, so that's our first step. Okay, then after that, this 60 degrees, well, how do we draw that? So we put our protractor and boom, okay, you can see, put our protractor here, measure off 60, and then we just draw a line here, and this line will be, you guessed it, since it's 50,000 newtons, that will be 50 centimeters, so 50 cm. And after that, we were to remove the ruler. And okay, how do we close up the parallelogram? Okay, I'm going to show you a quick tactic to actually draw a parallelogram. Don't need to use any set squares or anything. You only need two things, a ruler and a protractor. So because if this is 60 degrees, this angle will be, you guessed it, it's 120 degrees. How long do I draw it? Doesn't really matter. You just draw it all the way. And then after that, just move your protractor all the way to the other end, draw again 120 degrees, because corresponding angle to this will be 60, will be 120, and then you just draw that line, and where it intercepts, you will see that actually forms a parallelogram. So resultant force will basically be where you start off all the way to where it ends, and you just draw it. And for resultant force, we just represent it by having two arrows. So you can see the two forces of 75,000 and 50,000 newtons, we represent it by using one arrow, and the resultant force, two arrows. Okay, and how long would that resultant force be? So if we were to use a ruler to measure again, that would be about 10.9 cm. So if you convert back 10.9 cm, that will be, yep, 109,000 newtons. Okay, and finally, what's the direction of the resultant force? Okay, so to measure direction, we don't say that it's west, because we don't know whether upwards is north. They didn't really tell you that, right? So anyway, it's not exactly west also. You can see there's a certain angle. It's not perfectly horizontal. So our direction, you will always have to measure it with respect to one of the forces, either the 75,000 or the 50,000. So maybe for simplicity, we just use the first force, which is 75,000, put a protractor here, and you can read off this angle. What is it? This is about 23 degrees, and you can see as it goes down, which direction is this? Okay, it is actually anti-clockwise, right? So we don't say down now, we say anti-clockwise, because this goes in this particular direction. Okay, so hope you found this video helpful. Once again, that's the parallelogram law of finding the resultant of two forces. Okay, all right, see you guys soon.
Okay, so 在这个 video 呢，它就是教你怎样画一个 parallelogram 出来 to find the resultant force. Okay, so first you have to determine the scale. Okay, 因为我们只要知道讲说，它给你的那个space 不多，所以你就是要找出一个适合的 scale to draw the corresponding forces 出来。So 在这边它用1 cm 等于10千牛顿，所以刚才那个它写讲错，不是50 cm 啊，它应该是5 cm 的。So 你就 following the force given, then to draw out according to the scale that you have decided. Then at the certain angle, then after that you draw out 那个 parallelogram, 从头接到那个尾端 of the parallelogram, that will be your resultant force. Then after that, 你就再 set either one of the force to find the angle, then 你就会找到那个angle, okay, the resultant force acting at a certain angle to that force. Okay, 所以这个就是 how to find, okay, the resultant force when the two forces are not perpendicular to each other. Okay, 所以有4种方法。 OK，so 这个就是刚才我讲的。OK，在 experiment wise 呢，OK， 我们会有一个apparatus to help us to determine the resultant force。这个 what we call as a vector force table kit。OK， 就是说，如果它有 more than 2 forces acting on it 的时候呢，你就可以用这个 vector force table kit to determine the resultant force。所以下一个 video 就会教你们怎样找出那个resultant force。这个就是给你们一个 reference 这样子啦。OK，so please take a look at.
Okay, so here's the force table for the experiment. And what I have set up here is our 3 vectors. And you can see right here, at 0 degrees, we have angle markings on the outer edge of the circle. At 0 degrees, we have a piece of string that's tied to this little black ring right here. Goes over this pulley. And then I have this hanger. Now, on the hanger, we have 200 grams. The hanger itself is 50 grams, and then I have another 150. So there's our 200 grams pulling on this black ring up here at 0 degrees of direction. The second vector, vector B, is right here. I have my hanger at 70 degrees, and on the end of the hanger I have a total of 100 grams. And then vector C is over here at 135 degrees on my circle, and there is another 100 grams pulling there. So these 3 strings right here, that one, and that one, these represent vector A, vector B, vector C. And as we said, because forces are vectors, these 3 pulling forces are equivalent to that resultant vector that we found of 232 grams at 45.2 degrees. So you guys should watch that first video in Canvas where we do the addition of vector A, B, and C and get the resultant. All right, so again, what we're saying is these 3 pulling forces are equivalent to 1 pulling force of 232 grams at 45.2 degrees. So I could replace these 3 strings with 1 string right at 45 degrees approximately and have 232 grams on that, and that would be equivalent to these 3 pulling forces. So the challenge is, if we want to balance the forces on this ring, if we want to get this ring so that it's centered on this post, so all 4 forces cancel each other, what I need to do is pull directly opposite 45.2 degrees. Because again, these 3 together are pulling at 45, so I have this string set at about 225 degrees. Okay, that's 180 degrees away from the 45. And because these 3 strings together, we said, are pulling with an equivalent 232 grams, I should put about 232 grams on this hanger so that this 4th string is pulling with 232 grams directly opposite the resultant. So I'm going to throw some weight on here. We've got 50 already with the hanger. Here's a 100, that's 150. Another 50 is 200. Here's 220. Here's 230. And you can start to see that this ring is moving a little bit. I'm going to put 5 grams on there, and let me adjust these strings. That is pretty close. It's definitely between 230 and 235 grams. So it looks like we've confirmed that we can treat these forces as vectors. Okay, that's it. Bye-bye.
OK，so 在这边呢 as long as 你要把那个 center 的 ring，OK， 把它 make it in 那个中间那个 ring make it into center， 那个你就会找到它的 resultant force 的。这个就是 how the table vector table kit，OK， help you to find the resultant force。 Okay. So 这个是一个 examples, okay, we can look at it, okay. So 这个里面呢是一个 leaf 来的啦 ，okay. 所以呢 leaf 呢它是上下，所以呢我们有 two forces acting on it. One is the reaction force, which is acting upward, and one is the weight, which is acting downward. Okay. So the passenger, okay, of mass of 60 kg is in a leaf. So sketch the free body diagram in using W to represent the weight and R as a normal reaction. 就是在这一边哦。So B, calculate the magnitude of the normal reaction, okay, when the leaf is in stationary. Okay, so when in stationary, 我们就知道讲说 the two forces are balanced. So in another words, 就是说你的那一个 resultant force is equals to 0. Okay, so 你的 reaction force is equals to your weight. So 我们上一个去年我们的那个 chapter 2的时候，我们有学到 how to find weight. Medima is equals to mg. So m is the mass, g is the gravitational field strength, which is the 9.81. So your reaction force when the leaf is in stationary 就是588.6. Okay, so next, moving upward with an acceleration of 1.2. So 我们知道 to force 如果关系到 acceleration 的话，这个就是它的 formula. Force is equals to ma. Then 它 moving upward 嘛，当它 moving upward 的时候 reaction force 会比较多过你的 weight. Okay, reaction force 会比较多过你的 weight. So 我们在这边我们就是maybe 我们先放这样子先啦。Okay, plus negative weight 啦 equals to ma. So 你的 R minus W is equals to ma. So 你的 resultant, 你的 normal reaction will be ma plus W. Okay, so it will be equals to m 是我们的60加 1.2， 然后再加588.6， 所以答案就是660.6 Newton。Okay, next 呢就是 you moving with a uniform velocity 也是一样，这一个 keyword 是要跟你讲说 ，OK, stationary 跟 uniform velocity 呢就是要跟你讲 the two forces acting on the body are balanced, so the resultant force is equals to 0. Then 我们的 normal reaction 跟我们的 weight 是一样，所以就是588.6 Newton. Okay, so this is how resultant force questions will be asked, okay, in exercise or in also exams. Okay, so 这个接下来你们可以自己回去 ，OK， 去自己 stop 这个 video， 然后再给自己一些what do we call it as the 那个看你们会不会回答 ，OK。So 在这一边就是 ，OK， 我要着重在这边。OK, the reading of the weighing machine is greater than the weight of the object. So leaf is actually moving up with an acceleration. OK, 这个是 answer 是 moving up with an acceleration. 因为你不要忘记，当你的 leaf moving up 的时候，你的 gravitational force of your body wants you to go down. OK, wants you to go down. So as a result, 你的 body 会 put more weight onto the weighing machine. That's why 你就会 have a greater what do you call greater value, greater readings on the weighing machine. Okay, so that's all for the first subtopic resultant force. Okay, so 有什么不明白的，我们就是在when we meet face to face 的时候，我们再讨论多一点呢，还是你可以做多点 exercise，让你更加明白。Okay, thank you.